Let's factor these. All right. Number 1, x squared minus 13x minus 48. Class, yes or no? Is there a greatest common factor? No, there's not. There is no greatest common factor for number 1 because these two have an x in there, but this one does not. So a common mistake is to say, oh, there's a greatest common factor of x. That would be wrong. The second thing is look at the constants. This is an even, this is odd, this is just a 1, so they have nothing in common. Next thing I'm going to do is I can just find my a, b, and c. And I can just use my x. My a times my c value, 1 times negative 48 is negative 48. And my b value is negative 13. When the numbers get large like this, here is a strategy that I like to use. I like to write out all the factors of 48. 48 times 1. And I like to make the larger numbers on the left side. 4 goes in what? 12? 5, 6, and 8. Did I miss any? Which one am I going to use? Did you see why I chose to pick the bigger number on the left side? So you can kind of see, well, if I subtract 16 minus 3, it gives me 13. Do you see that? So at least now I can start with these two numbers. And now I need to think about which two numbers will multiply to be negative 48 and add to be negative 13. So the negative 16 and 3, these become my binomials. That's a positive, and that's my answer. Raise your hand if you got that. Now, let's make sure we're on the same page. In factoring, this is not work. This just helps us get us thinking about it, but it is okay to go from here to here without copying from a friend. It's okay to do it mentally. Raise your hand if you don't need this. Okay? Eventually, when they get a little bit bigger, you might. Let's look at question number 2. Number 2 tells us 3x to the 4th plus 3x to the 3rd minus 6x squared. I want you to notice something here. This exponent is what number? Class, what is half of 2? That tells me that in this trinomial, there's 3 terms. I can factor this to get 2 binomials. Look over here. Class, what's half of 4? 2. Although this is a trinomial, I cannot use the Xbox method yet. Class, what's the first thing we need to do? The greatest common factor. Okay. Now I'm going to show you guys a strategy I might teach an Algebra 1 student, like a 9th grader. I would not recommend doing this for every single problem. Hopefully you see it, but I just want to kind of visualize what the greatest common factor is. If you broke all of these down into their prime factors, you would get something like 3 times x squared times x squared. 3x to the 3rd would be 3 times x squared times x. Negative 6x squared would be negative 1 times 3 times 2 times x squared. Class, what do they all have in common? So I'm going to circle the 3's. Pay attention. I'm only going to write this 3 once. And then you guys said the x squareds. Class, what did I not circle? X squared. X is positive. Yes, that's where I write the plus. And minus 2. So 3x squared times the quantity x squared plus x minus 2. Here, we found that the greatest common factor is 3x squared. You can always check your answer by distributing, and then just look inside there. Can you factor again? In terms of the greatest common factor, you can't. Now, What is half of 2? 1. So that means we can try now to see if we can factor that using x box. Now think about it. You really don't need the box until your a value is greater than 1. 2, 5, 6, 7. A times c is b value. 2 numbers that multiply to be -2 but add to be +1. So let's write that, 2 and -1. Now a common mistake is not to write the 3x squared. That's part of our problem, so don't forget that. It just keeps falling down. Here we have the variable x. My 2 here is positive. And the purpose for us to factor is to connect that to yesterday's lesson, is now I can use multiplicity to actually sketch that by hand. Does that make sense? So here we just factored 2 problems.